Okay, we've got another theorem to prove here. It is called the vertical angle congruence theorem. So, based on the name, it might lead you to believe that if I have two angles that are vertical to each other, they will be congruent. And that is exactly the statement. So, if two angles are vertical, then they are congruent. So let's logic through this for a second. So this is, I think, one of the more intuitive theorems that we have, just based on the diagram. So if I draw a quick diagram here, so let's say I've got two lines that intersect like this. My vertical angles are, of course, these angles that are across from each other. I'm going to label them here 1, 2, 3, and 4. So, for example, 1 and 3 would be a pair of vertical angles. And you can imagine if I kind of hinge these two lines back and forth, as 1 gets smaller, 3 will get smaller as well. And as 1 gets larger, 3 will get larger. And so they're very much dependent on each other. Angle 1 will always be congruent to angle 3, and angle 2 will always be congruent to angle 4. So that's what our goal is to prove. And we'll just jump right to it. So I need some givens, and then I need a prove statement. So here's the kind of tricky thing, is that everything I'm going to pull is just from the diagram here. So I don't really need a given. I'm going to go ahead and give it one though, and just say that angle 1 and angle 3 are vertical. And the reason for that is I really want my given to reflect what's in the hypothesis of my statement if two angles are vertical. So I'm just going ahead and state it, angle 1 and angle 3 are vertical angles, and then use that. And then what I'm trying to prove is that angle 1 is congruent to angle 3. So that's what I'm trying to show. Let's go ahead and draw up our proof. So I don't like that line. Let's start over. That's slightly better. So I'm going to start off with a statement that, number 1, angle 1 and angle 3 are vertical angles. Okay, vertical angles. That is given to me. Now, many times, I'm just going to pull that from the diagram, which is actually something we're going to see here in a second. So how can I go about proving this? Well, up to this point, all we've really talked about as far as angle pairs go has been talking about supplementary angles. And so I can actually, here's the great thing, is that I can actually use a theorem that we just recently proved, and that is the congruent supplements theorem. So if we look at angle 1, angle 2 here, we can tell that they're supplementary, and we're going to talk about why in a second. But angle 1 and angle 2 will be supplementary to each other, and angle 2 and angle 3 will be supplementary to each other. And so if I have two angles that are supplementary to the same angle, which is the congruent supplements theorem, then they'll be congruent to each other. So it's just a question of how I'm going to say that. So how do I know that angle 1 and angle 2 are supplementary? And the answer is because based on the diagram, they're a linear pair. So I need to say that in my proof. I'm going to start off by stating that angle 1 and angle 2 are a linear pair. And so I was just talking about how normally I'll pull the fact that two angles are vertical from the diagram. And so when I go to give a reason here, how do I know that angle 1 and angle 2 are a linear pair? Well, the answer is I'm pulling it from the diagram. And so this is there's only a couple things that I can do this for, but a linear pair is one of them. I'm going to say assumed from diagram. Assumed from diagram. Okay, so there's only a couple things I can do that for. This is one of them. Vertical angles are another one, but this is not something that we should be using all the time. So angle 1 and angle 2 are a linear pair, and as long as I'm at it, I might as well talk about angles 2 and 3. Angle 2 and angle 3 are a linear pair. All right, this is also assumed from diagram. You also notice, of course, there's nothing to cite here, because again, it's just coming from the diagram, not coming from a previous statement. So now I can jump into something interesting. So what do I know about linear pairs? Well, according to my linear pair postulate, which is one of our accepted statements that we didn't prove because it's just one of those accepted things, we can say that angle 1 and angle 2, if they're a linear pair, that they will then be supplementary. And that's what the linear pair postulate says. So I'll just say that angle 1 is supplementary to angle 2. That's the linear pair postulate. If two angles are a linear pair, then they are supplementary. All right. So what do I need to cite? Well, where did I say that if two angles are a linear pair? I said that up here in statement number 2. So that was number 4. I can move on to number 5 and do the exact same thing for angles 2 and 3. Angle 2 is supplementary to angle 3. What does that tell me? Well, it tells me, how do I know that, rather? And that's from the same reasoning as before. If two angles are a linear pair, then they are supplementary. All right, and that comes from, where did it come from? I said that up here in statement 3 is where I said they're a linear pair. So now I have that angle 1 is supplementary to angle 2. Angle 2 is supplementary to angle 3. So what does that tell me? Well, based on the theorem that I just proved, I can use it to cut out a whole bunch of steps here and say that, well, if I have two angles that are supplementary to the same angle, well, those two angles have to be congruent then. And so I can actually jump to, and this ends up being not too long of a proof here, angle 1 being congruent to angle 3. Now, my reason is a little bit long. I have to state the whole thing. If two angles are supplementary to the same angle, then they are congruent. All right, and I just need to cite this then. So where did I say that if two angles are supplementary to the same angle? Well, I said that in 4 and in 5. And when I said that angle 1 and angle 3 are both supplementary to angle 2. So I will cite both 4 and 5. Great. So now I got the vertical angles congruence theorem, which says that if two angles are vertical, then they are congruent. So when I use this from now on, all I need to show is that if I have two angles that are vertical, I can immediately say that they're congruent, which cuts out, again, these 4 steps here and saves me a whole bunch of time. And so I can use this theorem whenever I have two angles that are vertical and would like to say that they are congruent to each other.